Okay, here we are. We're on lesson 5.4, part 2. The fun never ends here. Here's like a Venn diagram chart. I think we've done, if you've had me before for Algebra 1, you've kind of seen this: naturals, wholes, integers, rational numbers, irrational numbers. I just want to point out both rational and irrational are in the real category. They're both real numbers. However, irrational does not overlap with irrational. I don't know which one I said first there. However, naturals, like the number 4, is also a whole number. It's also an integer. It's also a rational, fractional, and it's a real number. Okay, now we're getting into these like imaginary numbers, Imaginary numbers are even separate from real. So you kind of have your real, and we call these like kind of non-real, and then your complex has both a real component and an imaginary component. So, whoa, do we have some stuff to learn here? Okay, I is defined to have the property that I squared equals -1. So in this, I want you to write down I squared equals -1. This will be a huge piece of information right there. The number is the principal root of -1. That means I is equal to square root of -1. I is called the imaginary unit, or the imaginary number. Pure imaginary numbers are square roots of negative real numbers. For any positive real number b, square root of -b squared is actually square root of b squared times square root of -1, or bi. Okay, because square root of -1 is I, and the square root of b squared is just b. All right, so that's kind of a lot. You probably got that written down. Let's take a look at it. Maybe I should put up here, I is equal to square root of -1. All right, I squared, if I were to show my work on this, I'm going to do this in a different color. Make sure you have this chart as well. Square root of -1 times square root of -1. Well, that's going to equal, what's the square root of George times the square root of George? George! Square root of -1 times the square root of -1 is just -1. Okay? You need to know that without a shadow of a doubt. I squared is equal to -1. You're going to use it over and over again. Okay, I to the third power is square root of -1 times square root of -1 times square root of -1. This part, well, we've already figured it in the previous one, is -1. And what is square root of -1? I. So I'm going to take -1 times I, or just -I. All right, I to the fourth. That's square root of -1 times square root of -1 times square root of -1 times square root of -1. This part is -1. This part is -1. What's -1 times -1? 1. I to the fifth. Square root of -1 times square root of -1 times square root of -1. All right, I got a lot there. This part, I'm going to write, is -1. This part is also -1. But what do I have dragging along behind that I don't want to forget about? Square root of -1. But I don't write square root of -1. I write I. Okay? So negative times negative is positive, and now I have I. I to the sixth, square root of -1. Okay? Do I have 6 of them? Yeah. This part is -1. This part is -1. This part is -1. Well, -1 times -1, 1. And now I have 1 times -1, which is just -1. Does it seem like dots and dashes or something that we're playing right here? Okay. Now, I'm going to do a little shorthand. I to the 7th. There's this. Repeating this. There's the 6th power. All right? And then I have to take it times 1 more, square root of -1, right? Well, this part just so happens to be -1 times -1 times, -1. We're going to be careful with that eraser. You see, it's about ready to, times -1. And then I have to take it times I. So I actually have negative times negative times negative, which is -I. Okay, I to the 8th. Okay, remember this is going to be -1. This, I'm just not going to rewrite the whole thing. We have -1. And once again, I have square root of -1 times square root of -1. All right, what is this equal to? Well, it's -1 times -1 times -1. Those are these three right here. This is also a -1. Woo! What's negative times negative times negative times negative? +1. I want to check this out for you, or show you this, because you're going to be so fascinated, because this is so exciting. -1 matches with -1. -I comes down here and goes with -I. 1 comes down here. Anybody want to predict what the next one would be? Ooh, yeah. It would be I, and then you start the rotation over again. And then you go back to -1. Okay, enough of that. As long as you got the chart, we're good. Okay, when we're simplifying square root of -28. All right, we're going to put the -1 over here. We're going to put this 28 over here. This is I. You're like, oh, I was sick of watching that before, but now you got to use it. Perfect square number that goes into 28, 4 and 7. 4 is your perfect square number. So I actually have square root of 4, which is 2. Then we write the I, and square root 7 is at the very end of the line. He's like, I'm a radical. I'm an irrational number. I'm at the end of the line. Even non-real numbers come ahead of me. Even the imaginary ones beat out the irrational numbers. Okay, let's try it again. Numbers 2, 3, 4, and 5. Here we go. Number 2. You should have, let's do this. Here's a trick that I do. What's a perfect number that goes into 32? 16. You could use 4 and 8, but then you got to do double the work. So we're going to go -16. See how I put the negative with the perfect square? And then I got a 2. This square root of 16 is 4. The negative comes out as an I, and you hang around with the square root 2 at the end. Okay, square root -144 y to the 6th. So I'm going to do this part, and then this y to the 6th, I don't know, I'm going to do the work the long way here. So I've got y squared, y squared, y squared, 2, 4, 6. This is 12i. Square root of 144 is 12, the negative comes out as an I. Weird, weird. Square root of y squared is y. Square root of y squared is y. Square root of y squared is y. 12i y to the 3rd. Believe it or not, this should actually be absolute value of y to the 3rd. You're going to put it in your notes that way. Am I going to deal with that too much? I don't know. I think the 3. I'm going to do a quick little gander here. I don't know that I can. Uh-oh. Uh-oh. If I can find an example where I'm supposed to put that little 3. Okay. We're going to leave it there. I'm not going to get too worked up about that. Okay, here we go. Square root of -50x to the 5th. The more I think about it, I bet that goes on the inside. All right, let's go back here. Square root -25, because 25 goes into 50, and then 2. 25 times 2 is 50, so square root of -25 times square root of 2. And then I got x to the 5th power. X squared, and then an x. 2 is 4, and there's actually a little 1 here, even though we don't see it. This is a 5i. We have a square root 2. We have, oh, what's the square root of x squared? X. Square root of x squared again is x, and square root x. Rewrite it in the correct order. I have 5i x squared square root 2x.
Lucas Gasper, Hannah Newton, Hannah Baker.
Irrational numbers, the square roots go at the very bottom. Sorry about the announcements. This one, I have square root -100 times square root of a to the 4th times square root of b squared. This is going to be 10i. I don't know if you can do this by yourself. A squared. B. And we're going to leave it. We're done with that one. Okay, now these, oh my gosh, you got i's, you're going to remultiply them. My suggestion is you think of this as just like -3x times 2x. Don't let it scare you. -3 times 2 is -6. I times I is I squared. The only difference is you guys know what I squared is. You can never leave an I squared. What is it? It's actually -1. Well, what's -6 times -1? 6. So this actually comes out to be a 6. Let's try another one. Number 7 here. 3i times 5i is 15i squared. I squared is -1. Most of you won't even write out that step. You'll skip down to -15 and call her good. 6 times -2 is -12. I times I is I squared. Now that's -12 times -1. What is that? 12. Okay, let me finish off this one. There's my kids coming in. I've just got to get it done. Negative square root -4 times 3 times square root -2. This is 2i. We cannot multiply these first. When you have negatives, the rules don't exist like they used to where you can multiply them because they're imaginary numbers. Times square root 3 times square root -2. Oh, wait, that comes out to be, I'm recording, just go ahead and sit down. So this comes out to be I square root 2. So now I have 2i squared times square root 6. I squared is -1. Well, -1 times 2 is 2. Square root 6 doesn't reduce, you just leave it. Okay, let's try another one. You got to pull out the negatives first. You're going to have I square root 2 times I square root 6. I times I squared. Square root 2 times square root 6, square root 12. Ooh, that reduces some more. I squared is -1. Square root 4 times square root 3. The square root of 4 is 2. So 2 times -1 is -2. Square root 3. Let's try another one here. We got 5 times I times square root 4 times square root 6 times 3 times I times square root 18. Woohoo! 5i times 2 times square root 6 times 3i times square root 9 times square root 2. I'm running through this one. 5i times 3i times 2, all the non-irrational numbers. 5 times 2 is 10, 10 times 3 is 30. You got a 30i squared. This, ooh, I should have thought about that earlier. Times 3 times square root 12. Now it keeps reducing. 30 times -1, I'm recording. Times 3 times square root 4 times square root 3. So I have this is -90. I'm afraid I might have made a mistake on this because I'm speeding through it. This is -180 square root 3. Woo. See if we can find a mistake on that. All right. I to the 35th, I'm just going to point out how this works. This is an I to the 34th. Why? Because we want an even exponent. Because now I can take I squared to the 17th. 2 times 7, power to a power, multiply to get to 34. Ooh, what's I squared? -1. -1 to the 17th power is going to be a -1. I is still hanging around down here. Well, I times -1 is -I. That's where that answer comes from. There's kind of a quick explanation. All right, let's try it here with I to the 37. So you have I squared. If you take it times, what is it, 19? No, I gotta take it times 18. I'll get 36. That means I have another I out there. That's a load, isn't it, right there? So I have I times I squared is -1 to the 18th power. Well, if you take a negative number times itself 18 times, it comes out to be +1 times I. I guess that's a time right there. That's a +1. So 1 times I is 1. This one, I have an 80th, so I can do I squared to the 40th power. 2 times 40 is 80. I don't even need to put an I out in front. I squared is -1. -1 to the 40th power. If you take -1 40 times, who wants to say that? You would have, a +1. And that ends the lesson.
Pretty sure I got in on that a little bit.
Yeah.